There's a lot of confusion surrounding upscalers nowadays. Like, which one should you use? Which one looks the best? Which one gives you the best performance? It's all up in the air and everything's anecdotal. Nobody gives you a clear answer because a lot of these upscalers are extremely viable. As you can see, AMD's FSR2 is supported in so many games. DLSS is supported in all of these games. Nowadays, Intel's XESS is getting really close to that kind of support list. 50 titles now. But does Intel's XESS look as good as these other upscalers that have been around for longer? And with the power of spreadsheets, we will put this all to rest. Now, just a disclaimer, I do not own every single one of those freaking games I just showed you on that list. That is like impossible. But I do have 7 games here today that support a decent variety of upscalers for us to take a look at. To show you guys the visual differences with these upscalers, I'm going to be using the performance setting on all of them. That's because it forces them to upscale from the lowest base resolution, which is extremely challenging and pushes them to their limits. This will really weed out which ones are better than the other ones in certain scenarios. And we're going to take a look at the FPS performance on each brand of GPU right after we look at the visuals. Starting out with Cyberpunk here, it does support every single upscaler, so XESS, FSR, and DLSS, so it's a really good example to show these off. And honestly, this game has amazing upscaling in general. All these upscalers perform really well, but I want to look at in particular, look at that little grate on the top of the fridge behind the guy at the bar as well. Look over at FSR, those grates on the fridge look wavy and weird. You would think that's a problem with FSR, but native performance has the same issue. While if you look over at the right, XESS and DLSS don't seem to have that problem. And I think the way that they're able to fix this is because both of these upscalers use deep learning to upscale in a more intelligent way than FSR and native. So I think this is one of the instances where Nvidia and say Intel or even AMD, when they talk about their upscalers, that it can look better than native. But we also need to look at the shimmering effect in this puddle. Whereas in native performance, it looks pretty natural, but in every single upscaler, it does look a little odd. And I see actually the worst performance here from XESS, which kind of goes to show that every upscaler has its strengths and its weaknesses. But there's one other thing I want to show you in this Cyberpunk run, and that is these fences. These upscalers can have a lot of problems with really fine details, and sometimes they just disappear. And that is with very good reason, because when you see what kind of image these upscalers are working with, so let me show you what 720p actually looks like. And at those lower resolutions, those fences, the pixels that make them up, barely exist whatsoever. So it's actually really impressive if any of these upscalers can get good detail from what it's trying to render up from. Moving on to Witcher 3, the clearest standout is DLSS looks so much sharper. The other ones look just kind of blurry, and if you look in particular at FSR, there's a lot more shimmering on the wood planks on the ground. XESS seems to get rid of some of those issues, but XESS just lacks sharpness. Forspoken is our next title, and this game does support all of the upscalers, so good example to test here. As you can see, like, I don't think the game, it looks all that stable, even at native resolution. There's a lot of like waviness on like the little fences and stuff on the street here, and the buildings in the distance don't look that good. And in particular, look at this building with the bricks here on every single upscaler, and on XESS and FSR, it just looks weird. Like, I don't know what's going on there. It looks very unstable and odd. But if you look on the far right, DLSS looks stable and good. I actually think DLSS looks better than native in this game, and this is at the performance setting. So DLSS, again, just a standout that is just kind of killing these other upscalers. I didn't think it was going to be this much of a difference, but I'm kind of seeing that now. And lastly, we got to talk about Last of Us, and this game only has access to FSR and DLSS, so no XESS in this case. But when you're just walking around here, it's extremely hard to tell the difference between FSR and DLSS. I think FSR looks a little bit sharper overall than DLSS, but it's not like DLSS looks bad by any means. But the real difference comes when you walk up to this fence here. I'm gonna do a little thing where I kind of pan the camera back and forth. And in FSR, it struggles a lot more to recreate these really fine details in this fence, whereas DLSS does a surprisingly good job. And because of that, I think DLSS does still win in The Last of Us. But what if you don't have an Nvidia GPU, or what if you don't have an Nvidia GPU that supports DLSS? This is a real shootout between what looks best between FSR and XESS. Back in Cyberpunk here, in the middle is FSR, on the right is XESS, and on the left I just have the native image for you guys to reference if you need it. First, I want to look at this texture on the wall as you go outside here in this benchmark. As you can see on FSR, it's kind of like shimmery and odd. I don't know. The artifacting is pretty weird looking, whereas XESS seems to be a lot more stable and a lot closer to what native is actually saying it should look like. Then next, the barbed wire that you see on the left here, I think you get more of it recreated with XESS compared to FSR. I don't think FSR does a bad job by any means, but XESS does a little bit better. And then coming to the end of the benchmark, there are also these palm trees here. And the little hairs that stick off of the palm trees and the leaves up above, I think they look more stable on XESS than FSR. Again, don't get me wrong, I think FSR performs really, really well in Cyberpunk. And for an upscaler that's completely open source and works really well on almost every single GPU available today, it's impressive that FSR does such a good job. Let's go back into Witcher 3 and look at how these compare again. XESS's main advantage in the Witcher 3 is, do you see these wooden planks that are on the ground here? FSR and in native, they look shimmery and odd. There's some weird filtering things going on, but XESS actually fixes this issue. Now, in terms of sharpness between these, I don't think either of these look nearly as sharp as what native performance looks like, but they look decently good. And other than the shimmeriness that's solved by XESS, I don't think there's a major advantage on going on either upscaler in this case. In Forspoken, it really seems to be personal preference. I mean, in the foliage, so the grass and stuff like that, it seems like XESS leans more towards sharpness and FSR is a little bit softer. And if you like the sharpness, then cool, but they both have some artifacts in the foliage. However, in the city portion of the game, I think the buildings look a lot more stable on XESS compared to FSR. If you look in the distance here with the vertical lines with the tall buildings, I feel like it filters it out better than FSR does. And FSR seems to look kind of shimmery in the distance compared to what XESS is offering us in this case. So it seems like in general, FSR struggles more with shimmeriness than XESS does in comparison, which I'd also stretch to say that XESS usually looks better than FSR. Just how they look, it doesn't matter if they don't give you good performance. So let's check out on all of these graphics card brands from Intel, Nvidia, and AMD, which upscaler gives you the best performance overall. So just like how the implementations of these upscalers can change a lot visually game to game, also their performance can change quite a bit as well. Just to kind of start this off here, because DLSS was pretty much the best looking upscaler, we're going to show the RTX 3080's performance first with all of these different ones. And with the quality setting from DLSS on the RTX 3080, I saw an average of 27% performance uplift compared to FSR, which was extremely close at 28%, so basically margin of error. And then on XESS, it was only 17%. Now granted, I was only able to test XESS on 3 games on the RTX 3080 from Nvidia, and that was Cyberpunk, Shadow of the Tomb Raider, and Witcher 3. So those numbers might change if my sample size was a little bit bigger, but unfortunately that's all I could do for you guys. But still brings up the question, why is this performance uplift lower than the other upscalers? And that's because if you aren't on native Intel GPU hardware, that is the ARC graphics cards, you do not get to use the hardware acceleration for XESS that is available on those GPUs. Although unlike Nvidia, who locks down their upscaling technology, DLSS, to just their native hardware. Instead, Intel's XESS does have a DP4A fallback layer instead of its XMX engine on its Intel GPUs. But DP4A cannot compute as quickly as the XMX engine on Intel GPUs, so you get a little bit more overhead, which makes it run slower on non-Intel GPUs in general. And I bet you're also thinking, why didn't you test the RTX 3080 in Forspoken? It has XESS, and you can use that software compatibility layer, but what I have to tell you is that Forspoken does not allow you to use XESS on anything other than Intel's GPUs. And maybe they just decided, hey, if you need an upscaler, you just use FSR, because maybe they couldn't get XESS to get anywhere close to the performance of FSR in their game. So you can only use Intel's XESS and Forspoken on Intel's GPUs, which I found pretty odd, but also kind of interesting at the same time. However, also on the 3080, let's look at how much FPS uplift these upscalers got when on their performance setting instead of just the quality setting. So FSR, I saw an average of getting about 51% performance uplift. XESS got about 35%, so much lower, and DLSS got 48%. So FSR and DLSS were pretty close, pretty much again within margin of error with each other. And seeing how much better DLSS looked than the other upscalers on average, it's pretty much a hands down, you just use DLSS if you have an Nvidia GPU. So that is kind of a selling point, and Nvidia isn't wrong for talking about that in all of their marketing. DLSS genuinely wins if you have an Nvidia graphics card that does support it. However, what if you don't have a GPU with the amazing technology that is DLSS and you have to use FSR or XESS? I think this is a crazy cool question, especially if you have an AMD GPU. Which one do you use? In this case, I have the RX 6700, and at quality settings, FSR on average gave us a 47% performance uplift, while XESS only gave us 25%. Which is a pretty big difference overall. FSR's performance uplift at quality is nearly doubling what XESS is offering. That's also obviously because the 6700 is not an Intel GPU and it can't use that hardware acceleration that Intel GPUs have for XESS. That's why on average with the 6700, FSR nearly doubled the performance uplift we got on XESS. That was in The Witcher 3, where FSR quality got a 73% performance uplift. XESS, surprisingly, it wasn't that far behind in the grand scheme of things. It got a 61% performance uplift. So at least in this case, using XESS through the software compatibility layer didn't give that much of a performance hit compared to FSR. Let's also check out how much of a performance uplift this RX 6700 gets when these upscalers are at their performance setting. And on average, I saw an 80% performance uplift with FSR performance and a 52% performance uplift with XESS performance. And again, in The Witcher 3, these were surprisingly really close. And in that game in particular, it might be worth using XESS. That's because in The Witcher 3, I thought XESS in general did look a little bit better than FSR. So getting 132% performance uplift on FSR compared to XESS at 110% might be enough of a performance hit that you might consider using it in that case. However, we got to talk about how it is in Cyberpunk. And in Cyberpunk, FSR performance nearly doubled what kind of FPS you were getting with XESS. I did also want to point out, and I'm not sure exactly why this is the case, but at least on my RX 6700 at 1440p, it got really major performance uplifts when using FSR in general. I thought they were really high, and they're much further ahead than any of the average performance uplifts that these other GPUs got. The only thing I'm thinking right now is the 6700 doesn't exactly have the fastest memory bandwidth, it being on a 160-bit bus. Using these resolution upscalers, it doesn't have to use as much VRAM, which means that bottleneck of its RAM's speed isn't as much of a factor when upscaling. So that is a possible theory, but it might not be the case. So let me know if you know the reason exactly why this is happening. From a performance standpoint, I still think in general it's better to go with FSR over XESS because of that software compatibility layer that you have to use. But one day, because XESS, as we saw in Cyberpunk, I thought it looked better in general than FSR, even though FSR looked really good in that game. In general, maybe seeing how it is in The Witcher 3, it's possible XESS might be a better alternative than FSR in the future, depending on how good the implementations of it are in game. But what if you don't have to go through that compatibility layer for XESS? What if you can use it on native hardware acceleration? And that's what we have to test here. I do have my hands on an Intel Arc A770, and at the quality settings for these upscalers, FSR on this GPU gave a 27% performance uplift on average, while XESS gave 25%. On Intel's GPU, these are extremely similar numbers to how the RTX 3080 was going with FSR and DLSS. It's kind of just margin of error on the Intel GPU between FSR and XESS. So overall, if you're on Intel, in general, I found that XESS does look better. you might as well just use it. There's pretty much no downside. The only thing is that it isn't in every single game that's available. But the story does change a little bit when you turn these upscalers to the performance setting. FSR does kind of leap ahead a little bit, jumping up to 50% performance increase, while XESS only has 42% performance increase. So a little bit of a hit for XESS in general there. But you do choose to like omit the Shadow of the Tomb Raider result because it wasn't a very good implementation of XESS. It was just old and early. XESS's performance uplift on the performance setting, which is kind of confusing to say, but that jumps up to 49%, which basically makes it neck and neck with FSR's performance at 50%. Just kind of goes to show if your games have access to XESS and it's a good implementation of it on an Intel GPU, there's pretty much no reason to use FSR whatsoever. So hopefully in the future, more and more games get XESS integrated into them. I know it's still new. Maybe also with that software fallback on AMD GPUs, maybe that could also get better and you don't get as much of a performance hit going on XESS when you're on AMD's GPUs instead. Okay, but at this current moment, use XESS if you got it and you got an Intel GPU. There's pretty much no reason not to. Hey, me and another shirt. I want to throw in this extra upscaler. It's kind of a secret one just for you guys as a bonus. As you know, earlier in the video, I did get footage of Fortnite, and you might be wondering, Fortnite only has DLSS and another upscaler that is TSR. But that's exactly why I wanted to test it, is because TSR stands for just temporal super resolution, and this is baked in to Unreal Engine 5. So it's possible that every game that releases with Unreal Engine 5, which is going to be very common in the future, could release with TSR support. So how does TSR match up against the big boy DLSS? And from what I saw, it doesn't do that bad, but it does definitely break down a lot more in motion. If you see my little backpack on my character, it looks blurry on TSR compared to what DLSS is offering. But obviously DLSS is pretty amazing, all things considered. It's not that bad in comparison. And if you didn't have DLSS to compare it to, you'd be hard pressed to say that TSR looks bad or anything. So as a built-in upscaler, TSR is really good. My testing, I found out on the RTX 3080 on performance, DLSS gave me a 67% performance uplift, and TSR gave a 69% performance uplift. Nice. Overall, TSR is surprisingly very good. So what did we learn? Well, at least if you have an Nvidia GPU that supports DLSS, and at least in my case with the RTX 3080, you should just use DLSS. I mean, it in general is very consistent and looks better than the other upscalers. I mean, it has some disadvantages, but barely anything that I could see. And it performed about the same as FSR, AMD's alternative. So if you can use DLSS, use it. It's just clearly the best thing. And it kind of sucks that it's true that Nvidia's marketing that says that DLSS is the go-to upscaler. They're kind of right. Pretty much definitively takes the lead over anything else that I could compare it to here. But if you're on an AMD GPU, honestly, a decision, and you might have to just, whatever game that you're in, if you have access to FSR and XESS, you're gonna have to do a little bit of testing yourself to see which one genuinely works better for you. Because in a game like Witcher 3, I didn't see that there is that much of a difference in performance, and XESS in that case looked better. It's like, do you prefer the visuals of XESS from Intel, or do you prefer AMD's slightly better performance uplift using these upscalers? Whereas in other games, it can be a no-brainer to just use FSR and AMD's GPUs. For example, in Cyberpunk, the performance uplift was nearly double, and FSR didn't look that much worse than XESS in that game. It really is a game-by-game basis. There's gonna be better and worse implementations in every single game that you might play. So that's just some things to be aware of, and hopefully that can help you making your decision when you're playing certain games. Now, if you're on Intel, if you're playing a game that you have access to XESS in, I see no reason to not just use that over AMD's FSR implementation. XESS does use deep learning, more accurately calculate things, and get rid of a lot of the shimmering issues that FSR has in general. And at the same time, with Intel's hardware acceleration for XESS, there isn't that much of a downside and performance hit to getting that better visual fidelity most of the time. So if you're on Intel, just use XESS. This is all just kind of like stupid and funny because it basically just comes down to, if you're on that brand of GPU, you should use that brand's upscaler most of the time. It is what it is, I guess. With the help of the spreadsheet, we're able to figure this out. Put down all of the confusion and the anecdotal evidence that a lot of people claim to say that which one's better than the other one, which one gives you more performance than the other one. Does it really matter? And on each branded GPU, we were able to answer that question today. And in the future, things might change, but this should be pretty consistent for probably a year or two into the future. And again, screw you Nvidia for locking DLSS off to Nvidia GPUs. There's probably a good reason for it. Like, it's very good, and it probably does require some kind of hardware on Nvidia GPUs that they can't guarantee is going to be present on AMD or Intel's GPUs. Well, if you're at the end of this video and you're like, well, why doesn't every game just have DLSS, FSR, and XESS support in them? Because upscalers are good to have and they're not that hard to integrate. Well, Gamers Nexus did do a cool video recently on a news topic, kind of like Resident Evil 4 and Jedi Survivors are both AMD sponsored titles and they don't have DLSS in them. So people have had theories that it's possible that AMD does lock off DLSS support in their games, probably because DLSS is a superior technology. And then just a side note on Nvidia sponsored games, Nvidia did claim that they do not lock off competitors' technologies from being integrated into them at all. But that's kind of a nothing burger from Nvidia because DLSS is better, so why not just have FSR as well so other people who don't have your GPUs can still play the game. I think it'd be stupid for them not to, and it'd be bad PR in general. However, what I did find in any Nvidia sponsored games, I had Shadow of the Tomb Raider, which was Nvidia sponsored, and Cyberpunk, which is also Nvidia sponsored. Compared to the AMD sponsored games, Nvidia games tend to have a built-in benchmark in them, which I find funny because Nvidia does have higher quality visuals. I mean, technically their GPUs are better at ray tracing, and DLSS does also look better. It seems like they encourage their partners to integrate a benchmark into their games. But also in those games, Cyberpunk has FSR and XESS support, and Shadow of the Tomb Raider has, because it came out before FSR was even made, it has some version of FSR, but it's just called Fidelity FX CAS. But overall, it's kind of random what upscalers you're going to get into a game, and just kind of have your fingers crossed it has all of them, and that you can get the one that looks best on your GPU and performs best as well. But that's all I had to say on the kind of recent controversies that AMD had. And maybe you can check out Gamers Nexus video if you want to look at that in a more in-depth topic. Anyways, a final goodbye. See ya.